First question. Classify each statement as an example of classical probability, relative frequency, or subjective probability. Okay, now where does it come from? It comes from here. Right, so let me just go through a very brief one again. There are many ways people assign probabilities. Yeah, so basically there are three altogether here. Classical probability, or the probability that you don't need to run experiment. You know the answer. What's the chance you get a hit when you toss a coin? You know very well it's 1/2. Why? Because there are only two sides on a coin. You don't need to run experiment. You find out, okay, I think it's 1/2. No need. Yeah. So you know very well there are two sides. So every side has equal chance. One of the two of getting a hit and one of the two of getting a tail. Right. So this is called classical probability distribution. Classical probability assessment. Now it can also be that so that you see there are so many of you. So today we have about 130 of you log in for this lecture. So let's say there are 60 female students and there are 70 male students. Okay, let's say there are 60. I write it down here. If there are female students, there are 60. Okay, there are male students, 70. What's the total? 130 of you here. So if I were to pick up one of you, what's the chance that I pick up a male student? You look at this female. Every single student, either male or female, will have 1 out of 130. Every student has 1 out of 130 chance of being selected by me. So if there are 60 female students, what's the chance I pick up female? Will be 60 out of 130. What's the chance I pick up male students? 70 out of 130. Okay, so this is also classical probability assessment because you know the probability fixed already. You don't need to run experiment, find out, okay, what's the chance I will pick up a male student? No need, right? But for this particular one, for the one at the center here, the relative frequency is you have to run experiment, otherwise you won't know. So for example, you need to know how many days in a week people read newspaper. You cannot pluck from the sky all these figures. So you have to go and find out. You collect data, then you put up in the table, then only you do a calculation. You say, oh, okay, there are about how many people? Let me see. There are 44 out of 200 people that don't read newspaper at all. Right. So what's the chance that you will bump into this kind of people? The chance is 22% because there are so many people who don't read newspaper. Okay, and how many percent is that? It's 22%. So if you're running and just walking around that area, you have 22% chance of bumping into this type of people who don't read newspaper. Clear? Right. So this is called relative frequency, which is the same as getting this divided by the total. Okay, the last one is about subjective. Subjective is you wish you can get data, but you can't. Like election, weather forecast, you can't really collect data and find out the probability. Okay, so you can have some information, but the information may not be correct, or there will be a lot of changes, major drastic changes every time you get the data. Okay, so for example, like earthquake, weather forecast, and sports event, football match, or you have a marathon, who will win? You will know. Okay, so those are subjective probability. So let's look at the question. Classify each statement, whether it's classical. Classical, that means you don't need to run experiment, you know the answer. Relative frequency means you need to run experiment, you get the data and use a relative frequency table to tell your answer. Subjective is you want numbers, but you cannot collect any data. So if you look at this, you have to ask yourself a question whether do I need to collect data to know this answer? If yes, am I able to collect the data? So for example, the first one, the probability that a person will watch the 6 o'clock evening news is 0.15. The first question you ask in order to identify is, do you need to collect data to know this number, 0.15? If you don't collect data, would you know 0.15? The answer is no, right? You won't know it's 0.15. How about 0.25? So you need data. Are you able to collect data to know who watched 6 o'clock news? If yes, then it's relative frequency. If it's no, then it's subjective. Now, let's look at this situation again. You want to know how many people watch 6 o'clock news. So I can ask you, okay, I ask you a question. Do you watch 6 o'clock news? Then I pose up to you. You say yes, some say yes, some say no, some say yes, some say no. In the end, then I calculate. Okay, those who say yes is 15 out of 100. So that's how I collect the data. So I just repeat. When you read this statement, the first thing you ask yourself is, do I need the data to tell me this is a probability? The answer is always, of course, yes for this particular question. Then you ask yourself, am I able to collect data? The answer is yes. Then it will be relative frequency. Just use a short form to write. Okay, relative frequency. This is just short form that I write here. Yeah, it's not the official short form. Next question. The probability of getting at least a head when two coins are tossed is 3 over 4. Two coins are tossed. So what can be the outcome when two coins are tossed? You can have then and then this one. Only 4, right? Any more? No more. So getting at least a head. Which one is head? This one is head. This one is head. This one is head. So at least one of them is head. How many of them? 3 out of 4. Did you run any experiment to know this? No, I didn't. I just write down the outcome, right? Okay, so if you don't need any experiment to run this, to know this 3 over 4, then which type of probability that we use? Classical. Yeah, you want to write down? No experiment needed. This one is experiment needed. Experiment, that means you need to collect data, yeah? You run experiment, you have data, correct? So experiment needed, that means you need to have data. Subjective is cannot collect data. Not that you don't want, you just can't. Next one, the probability that a bus will be in an accident on a specific road is about 6%. Bus having accident on a specific road, 6%. This is the probability. Do you need experiment? Do you need data collection to know this figure? Yes. Are you able to find this data? In Singapore, do you think that there will be a department who takes care of this, all the accident happening in Singapore, and they know exactly where the accident happened? So at this particular, how many times already happened out of the total accident in Singapore? Okay, so you get 6%, right? So if you need data to tell you so, you need to collect data, that will be relative frequency. D, The probability of getting a diamond when a card is selected at random is 13 over 52. We know we have 52 cards in one deck of cards, right? Then how many types of shapes do we have? We have 4 types of shapes, right? Just to elaborate a little bit, if you don't play cards, you don't need to go and play card to answer this question. Yeah. So in a quiz or in the exam, we won't ask you anything about card. We know some students don't play cards. Yeah, it would be unfair if we were to ask you this question. So don't worry, we won't have questions on card. But this is just an exercise so that you can see. Yeah, so we have 4 types of shapes. So 52 cards. We have 4 types of shapes. So each type will have 13 cards. So it says a diamond is 13 out of 52. So it's just one type of shape, right? So do you run any experiment data collection to know this? No. We just do a very simple calculation. 52 cards, 4 shapes. So each shape is 13. So 13 out of 52. This is the answer. So this is also classical. Next question. The probability a student will get a C or better in a statistics course is about 70%. 70%. How do I know student gets C or better or not? Is there any data for me to collect? Yes, from the past. Yeah, from the past semesters. I may have 1,000 students, all this or that no I collected, and 700 of them. Let's say I have 1,000 students. Okay, 1,000 students, and 700 of them get C or better. So the answer becomes 70%. Yeah. So I can collect data, and the data can show me that it's 70%. Without the data, I don't know. So data is needed. Experiment is needed. So this is relative frequency. Okay, how about the next one? The probability that a new fast food restaurant will be a success in Chicago is 35%. This is your answer, 35%. And what is a story here? New fast food restaurant, a success in this area. So are you able to list down all the new fast food restaurant in Chicago? And are you able to count how many of them is successful? Okay, success, you have to define what is success to you when you do any research. Probably you say operate more than 3 years. That is considered success. So are you able to find out fast food restaurants in Chicago and how many have operated 3 years and above? At least 3 years. They want a new one, right? Okay, so you can just do a check and count. So you are able to get the data. And the data tells you that 35%, probably 35 out of 100, so 35%. So do you need the data to tell you the answer? Yes. Are you able to collect the data? Yes. So both yes equal to relative frequency. The last question, what's the chance that Team A will win the basketball match next month? Do you need the data? Yes, you wish you can, but are you able to collect this type of data? Who will win the basketball match next month? Maybe you have some idea. Yeah, Team A consists of two. Team A, okay. Team A has been winning all this while, but does it mean that Team A must win this round? Maybe not. So can Team A win? No one knows. You cannot know that no, it can be a very high chance of winning, but what's the chance? You are not too sure. You can only have a guess. Okay, you feel that maybe 90%, maybe 70%, right? So this is called subjective. Right, so this is how we define what sort of probability assessment. Now this will be very useful because you see, you saw things on papers, you saw information on MRT station, on magazines, on internet, everything. You would want to know how people come out with this number. 35%, how do they get it? 15%, how do they get it? Do they need data or they just guess? Okay, so this can be quite useful when you read the newspaper so that you know that how reliable are those information. Question 2, if 2 dice are rolled once, what's the probability of getting this result? So you have to refer to this. Refer to this. Okay, refer to this. What's the question? A sum of 5. You roll 2 dice and find out a sum of 5. A sum of 5. So you see which number plus which number will give you a 5. 1 plus 4. Okay, let me take away this. 1 plus 4 is 5. Then 4 plus 1, same. 2, 3, and 3, 2. Any more? No more. So what's the chance? 1, 2, 3, 4 out of a total of 36. So it will be 4 over 36. Okay, so you can turn it into decimal. What is it? 0.4 over 36, which is 1 over 9, right? So whichever you use. 1, 1, 1. Okay, next one. Note the keyword here, 3 or 12. So you're going to find 3 first, then you plus 12. Okay, each one divided by 36 because there are 36. So let's find out how many gives them a 3. So I have to take this away again. Which one give you a 3? 1, 1 cannot. 1, 2. 1, 2 and 2, 1. Then the rest cannot already. So 2. 2. How many give you a 12? 12. It has to be 6, 6. There's nothing else. 1. So this is 1. So how much is it? It will be 3 over 36. Okay, so you press calculator. 3 over 36 is just 1 over 12. Next question. What's the chance you get a double? What is double? What do you mean by double? We'll take this away. Double means this. Same number on both. How many of them? 1, 2, 3, 4, 5, 6. 6. So 6 over 36. So 1 over 6 is 17%, right? You can also put into decimals. The sum of less than 4. Less than 4 means, is 4 included? Less than 4. Which one give you 4? 1 and 3, 3 and 1 give me 4, 2 also give me 4, but I say less than, that means this one, the one, the one, the one. So anything above that will be more than 4 already. So what you have is just these 3. 3 out of 36. 3 out of 36. So again, it is 0.083. A sum greater than or equal to 10. Or, remember the word or. What are you going to do? You're going to add. What are you going to add? Greater than or equal to 10. That means 10. That means 10 or 11 or 12. So let's find out 10. 10. Which one give you 10? 5 and 5 give you 10. 4 and 6, 6 and 4 give you 10. What else? No more? There are 3. Plus 11. 6 plus 5. 5 plus 6 give you 11. And this one is the last one, 6, 6. So 2 plus 1. 2 for 11. 1 for 12. So you add up all together, 3 plus 2 plus 1, you get 6 over 36. 6 over 36 gives you 0.167. Okay, this one is quite straightforward. I leave number 3 for you. A very simple question. So the answer for $10 is just number 1. Okay, this one is 4 over 20 and this one is 16 over 20. Okay, this is a final, so you can try and see whether you got them. Yeah. Now you move on to question 4. To make things simpler, you have to find out this one. Okay, this is a number. So you find out how many times it occurs. So for example, you have 1, 2, 3, 4 in this wheel. You find how many 1, how many 2, how many 3, how many 4. Then total up is how many. So from there, you can actually work it out. Okay, so I leave this to you. Go to question 4. There are 6 packets, or not question 4, this is the next topic, 3.2, question 1. There are 6 packets of peanuts, 8 packets of raisins, and 2 packets of chocolate chips. If a packet is selected at random, what's the probability that it is a packet of raisins? So again, it'll be easier if we can just put up a very simple table here, right? So how many you have? You have, this will be the type. This will be the, you can see count. Okay, let's see count. Or you can see quantity. So the type is peanuts. The next one is raisin. The next one is chocolate chip, choco. How many of them? You have 6 packets of peanuts, You get 8 packets of raisins, 8 packets of chocolate chips. Add up all together, you get 16. So this is the total. Now we are ready to answer the question. What's the probability that you pick up you only pick up one, okay? You pick up a packet of raisins. Raisins. How many raisins you have? 8. So answer will be 8 out of the 16. So answer is 0.5. Raisins or chocolate chips. Okay, you have the magic word here. Or what do you do? Add. How many raisins? Raisin has 8. Or chocolate chips. Chocolate chips has how many? 2. So you get 10 over 16, which is 0.625. Yeah, the answer is right below here. Yeah. Then the next question, peanuts. Or you get another magic word here. Peanuts. How many peanuts you have? Peanut 6. Raisins 8. You get 14. Last one, not peanut. Peanut is 6. Not peanuts will be the rest. Yeah. So you can take the whole thing, 100%, take away peanuts. So peanut is 6. So you get 10, correct? So it will be 0.625. This one is quite straightforward. The next question also quite straightforward. I leave this to you. This is your homework. Okay, now let's go back to the slide. We are going to look at the addition rule. Okay, we have seen some of the rules which are you don't really need to remember, so you don't need to memorize, you just need to know how to use it. Okay, so now this is another rule that we'll be looking at. This is called addition rule. Okay, this addition rule applies to mutually exclusive events. So remember the peanuts and chocolate chips and raisins, they are individually packed. Okay, so if you just pick up one packet, how many things can you pick up? You can only pick up peanuts, or you pick up raisins, or you pick up chocolate chips. So you cannot pick up a packet which has raisin and chocolate chip inside. So it's, for example, this one is peanuts. Okay, the basket of peanuts. And this one you have basket of how many peanuts do we have? 6 or 8? Let me see. You have 6 peanuts, 8 raisins. You have 6 packets here and 8 packets here, which is raisins. So what's the chance that you pick up either peanuts or raisins? Then you just need to add them together. Okay, peanuts, there are 6. That's how you do, right? So you just take probability of peanuts, which is 6 out of, we have another one, which is another circle here, which is your chocolate chips, right? Choco, how many? 2. Okay, so total of 16 altogether, plus raisins, 8 over 16. So you just add in that way. So when you have an or, you just need to add. Okay. Is it possible to pick up peanuts and raisin at the same time when you only pick up one packet? Not possible. Okay, why? Because both events cannot occur at the same time. You pick up peanuts, you cannot pick up raisin. You only pick up one packet, remember? Or just only one packet. So if you pick up only one packet, you either pick up peanuts or you pick up raisins. You cannot pick up both. So the chance of you pick up peanuts and raisins at the same time, when you see and here, that means at the same time you have peanuts and raisins, the chance is not possible. Yeah, it is impossible. So the chance of doing that is 0. Let's look at some of this example about mutually exclusive so that it is emphasized that you understand. If someone, let's say we are having a lecture in Marina Square, then someone open the door and say, okay, I'm going to look at a female students. Okay, let's say this is a female students. Then another person comes and say, I'm going to find a students who is in the student club. Okay, let's say this is student club. Is it possible? I repeat the question. Someone come to our room, say, I want to find a female student. Then another person comes in the room, 2 different person now. Then the second person says, I'm going a student female student can be a student, a female student can be a student in the student club. A student in the student club can also be a female student. So these 2 events can happen at the same time. So they are not mutually exclusive. Okay. How about the next one? Now, same scenario. We are in a lecture hall in Marina Square. And someone came in, say, I want to select someone with type A blood. Second person comes in, and the person say, okay, I'm going to select someone with type B blood. Can both of them select the same student? One student which has type A blood and type B blood at the same time? No way, right? So the events are called mutually exclusive event, right? So there's no way that type A blood and type B blood can be exist at the same time in someone's body, right? So these 2 events is mutually exclusive events. How about this? Let's say I'm rolling a die, okay? And I tell you that I get an odd number. What is odd number? A die has 6 numbers, right? So odd number is 1, 3, 5. Then I tell you that I get a number more than 4. Is it possible? I repeat. If I tell you I get an odd number, can that odd number is a number more than 4? Yes. What number is that? 5. So these 2 events also can happen at the same time, right? An odd number can be a number more than 4. So these 2 events are not mutually exclusive. Okay, so this is just to emphasize what you have earlier. When you have, what do? You just add them together, right? When you have two separate circles and you want to find all, you just add them together will do. So same thing for this. Put up. This is put in another type of table, but the concept is the same, right? So for example, you are playing cards. How many color you can have in a deck of cards? You only have two colors. One black, another one is red. There are only two colors in the deck of cards. So what's the chance you'll get red card? The chance you get red card is 26 over 52. The chance black card will be 26 over 52. So what's the chance of you getting red or black, or means you're going to end up with a 1. That means for sure when I pick up any card from the deck of this card, I will get a card which is red or black. Okay, now let's look at these two circles which overlaps. So let me put in some story. Okay, this is student in student club. Okay, student who joins student club. Students who join student club. Okay, and this is student who do BDM. BDM is this module, yeah? Right, so I have two groups of students now. One group of students take BDM. And then another group of students who join student club. Can these two events happen at the same time? Can BDM student join student club? Can can students who join student club take BDM? The answer is yes, and is denoted by this. So there may be students who take BDM and at the same time they join student club, so they are inside here. So when you have these overlaps, when you want to find all, you have to be very careful. All always plus, no problem. But you take note that this group of people inside this, they appear here, they also appear here. Okay, so let's say the student who take BDM is 150. Then all the students who join student club is let's say 120. The student club has 120 students. And we know that there are students who are in student club who are doing BDM. There are 30 here. Okay, 30 students belongs to both. How many students taking BDM but not joining student club? This 150 is all, yeah? All. 150. This 120 is all. And we know that there are 30 students who join student club and doing BDM at the same time. So now I ask you, how many students take BDM but don't join the student club? Only 120 left, right? 150 take away 30, 120. Then how many of these students in the student club don't do BDM? it will be 120, take away 30 will be just 90. Okay, so what is the total number of students in this group? 120 plus 30 plus 90. Total 240. Right? You see that we cannot add this plus this anymore. We cannot add this and this together. When we add these two together, what we end up with? 270. Yeah. So you have extra 30 here because they overlap. Yeah. These 30 students belongs to here, belongs to here. When we total up like that, individually, we actually double count this number. Yeah. So what you do is, after you add this, so for example, you get probability of, the answer will be 120 over here. Okay, so 100 over 20. Oops. I need to get the total of the student who take BTM will be 150 over 250 altogether. 240 plus 120 in the student club. But don't forget we have to minus off something. Yeah, that there are 30 students who appear in both. The 30 students are the students who appear in in the BDM and also in student club. Okay, at the same time they do both, so that is 30. Okay, so now you see 150 plus 120 is 270 minus of 30, then you get 240. Okay, right. So you just need to know the logic behind. All right, so now I'm going to ask you using the card again. Just learn together. We just focus on the A's. Okay, the card has A, B, A, then 2, 3, 4, 5, 6, 7, 8, 9. Then you have to have the J, Q, K, right? Okay, so now we just look at the A. There are only 4 A's in the whole deck of cards. The rest are not A. You have 2 red and you have 2 blacks. Two red A's and 2 black A's. The rest are not A. So if I were to ask you, what's the chance of getting a red or an ace? Red or an ace. So whenever you see the or, remember you're going to add them together. Add, okay? We're going to add, no problem. So red, how many red? 26. How many ace? 4. Do you notice that when you do a circle like that, then you can see very clearly that this number appear twice. You calculate twice. So you just need to take away. Yeah, it's similar to what I have explained to you just now, right? So end up, you actually only have 28 instead of 30. Okay, right. So let's look at another way you can find probability. If I were to ask you this way, if you know I'm taking an ace card, I tell you that I'm taking an ace card. So how many ace cards are there here? You only have 4. Okay. What's the chance that the ace card is red card? If I've gotten an ace, what's the chance I get a red card? Then it will be just 2 over 4. Okay, 2 out of 4. Right, so when you are doing this type of question, you don't need to use a formula. You just need to straight away use this. 2 out of 4. Okay, but you just need to know the notation here. The line is just if. If I get an ace card, if I get an ace, what is the chance it is a red one? Okay, so it's just 2 out of 4. Let's look at another question. If you would like to use a formula, so no problem, but you don't really need to use a formula and you still can find out the answer. Of the cars on the used car lot, 70% have air condition, 40% have a CD. Yeah, on the used car, there are many cars here. They tell you 70% have air condition, 40% have CD, 40%. 20% of the car have both. 20% of the car have both. Okay, both. So you're only given those who tick. Then how about those untick? Will be the complement. You have CD, you don't have CD. You have aircon, you don't have aircon. Right. Then the rest of the number you just add according to the rows and the columns. 0.2 here, that means there are 0.7, no CD. Add up is 0.7. If 0.4 here, 0.2 here, then you're left with 0.2 here. So you can fill it up easily. If then the total must be a 1. So if this is 0.7, this must be 0.3. If this is 0.4, this must be 0.6 in order to get a 1 here. Yeah, total must be a 1, remember? Then if this is 0.5 already, then this must be 0.1 in order to get 0.6. So if the question would ask you, if you get an aircon, so where's the aircon? You basically will look at this. Okay, this row only, aircon. What's the total percentage of aircon? 0.7. Okay, so we get 0.7 here. Out of 0.7, how many have CD? 0.2. So 0.2 out of 0.7, you get this. So this is how you find out probability. Now this probability is called conditional probability because you are given a condition. The condition is if it has aircon. Yeah, if you have aircon. Now this if is very practical in your daily life. For example, you tell your mom, I need a new iPad. Your mom will say, okay, I'll buy for you if you do well in this semester. So the if will give you a condition, right? So the condition always come after the if. Clear? What is the probability that a car has CD player? If. Given that means if it has a aircon. Right? Okay, remember the condition always come after if. And we call that conditional, and the base will change. The base will not be the total, the base will be according to the condition. Right, so let's have a look at this. More conditional probability. You have a recent survey asked 100 people if they thought women in the armed force should be permitted to participate in combat. So this is your data. Let's look at this data. If I were to pick up anyone here, what's the chance I pick up someone who is male? How many males we have? Will be 50 over 100. Okay. If I were to pick up another person, yeah, different question already. What's the chance I will get someone who say yes, yes, 40 over 100. Okay, now I'm going to mix up two. What's the chance that you get male? And the person say yes. What's the chance you get someone who is male? And the person say yes, female should be able to participate in combat. Yes, male. What's the figure? 32. Yes, and male happening at the same time, 32. Okay, how about the one that we have finished just now? Male. What is the chance that I will get someone who is male or I get someone who say yes? Listen carefully. What's the chance I get someone who is male? If I get someone who is male, or that means the male can say yes, can say no. Or I get someone who say yes. So someone who say yes can come from male, can come from female, right? So I'm going to add this male and female and a yes. Or I just add, all right? But can the male say yes? Yes. Can those who say yes be a male? Yes. So they are not mutually exclusive. They are not two different circles, but there are some overlaps there. So if there are some overlaps, you have to take away the male and yes, the male who say yes at the same time, right? So the answer will be, the male will be this, 50. The yes will be 40. But you have to take away the male and yes. Male and yes, how much? 32. So how many ways the question can ask you? They can ask you only one thing inside. They can ask you two things with the and, two things with the or, and two things with the if. What's the chance that the respondent said yes? If the respondent was a female. Respondent was a female. So you look at this. Just look at this rule. Because it says the condition is a female, if the person is a female, right? So you only look at this rule. So what do you want? You want answer yes. Yes in female. So how many yes? 8 over 50. Straight away write this. From here, straight away you answer the question this. Okay, then you press the calculator to get the decimal. Find the probability that the respondent was a male, given that the respondent answered no. So again, this condition is no. Okay, the condition is no. So where's the no? Okay, this is the one. And what do you want? You want male. The male in this no group. So it will be 18 over 60. So from here, straight away jump here. Just ignore the formula. Okay, so this is the fourth type of question. This is the first type. This is the second type. This is the third type. And this is the fourth type. Yeah, this is the fourth type. The if is the fourth type. This is also the fourth type. Okay, that's all for the lecture. Let's look at the exercise and see whether you know how to do. If you know how to do this exercise 1 and exercise 2, that means you get the concept correct. A sales representative records the number of items sold in a day for the past 25 days. You have 25 days. You record every day. You record down how many items you sell. So in the end, you say that, okay, there are 6 days, you sell nothing. There are 10 days, you sell one item. So there are 5 days, you sell 2 items. Okay, this probably is a printer or something big that you sell very little, right? Okay, find the probability that the number of items sold in a given day is exactly 3. Exactly 3. So how many of the 25 days you sell 3? 3 days out of the 20. So you say 3 out of 25. Okay, find out the decimal, 0 point something. Less than 2. Okay, less than 2. Less than 2, does it include 2? No. Less than 2. Less than 2 means either 0 or 1. So it will be 6 over 25 plus 10 over 25. So you get 16 over 25. It will be 0.64. At least 3. At least 3. 3 or more. Okay, at least 3 means 3 or more. So 3 or more. So it will be 3 over 25 or 1 over 25. So you get 4 over 25 will be 0.16. At most 2. At most 2 means maximum 2. Maximum 2. So maximum, this is maximum. So anything below. At most 2. So it will be just 6 plus 10 plus 5 over 25. So it will be 0.84. Next, exactly 3. Or, okay, we have an or here. Means you're going to add. Exactly 3 is how much? 3 over 25. Less than 2, less than 2 is from B. Okay, you get it, A and B. Less than 2 is 16 over 25, right? So you just add the actual cases, can add the number 0.12 plus 0.64, so you get 0.76. Okay, manageable for this simpler exercise. Now let's look at when you have 2 items in one table. Those who finish can move on to the next page. Consumers were surveyed on the number of visits to a new mall and whether they find it easy to locate certain stores. Okay, number of visits here and whether easy to locate certain stores. So for example, you have not been to Marina Square, then they ask you the first time you go, are you able to find the Marks and Spencer? It can be yes or can be no. Right, this group of people, they usually go there, so quite often they go there. This group of people, sometimes they go there. This group of people rarely go there, right? So each of them will be asked whether is it easy for you to find the store that you want to go to. Then you say yes, no, yes, no. Okay, so this is the data. Now let's look at what question can be asked from this data. You're going to pick up a customer. What's the chance that this customer finds it easy to locate certain stores? Easy. How many easy? Only easy. We don't care whether it's often or occasional or rarely, just easy. So we got to find out the total. We got to find out the total. So this will be 40, 30, 30. So you get 100 over here. 14 and 16 give you 30 plus 10, 40. So this must be 60. So easy. How many are easy? So the chance of, so you can use E as easy. Over the total, which is 100. Okay, then you can press the calculator. No need to press, you know it's 0.6. Next, often visit the store and finds it not easy. Often, the keyword is what? So which one are you going to look at? Should I change another color? Okay, use this one. Which number? Often, not easy. Often, not easy. Happening at the same time. Okay, this one happen at the same time. So 14. Okay, say often is O. Better write that down because it's an occasional. And not easy. Okay, you can write not easy, or you can just put a line on top. It's not easy. So you get 14 over 100. So it's 0.14. So this is second type of question. If you're done, move on to the next page. Next one. Or. What are you going to do with or? You're going to add, right? Okay, so you have two things here. Rarely and easy. So you're going to add so you get rarely, or you can just put R will do, yeah? Rarely plus easy. But don't forget, those who rarely go there will find it easy also. Yeah, these two can happen at the same time, so you have to take away. So rarely and easy. Rarely. Oh, I could write all over again. This is total. This is total. 40, 30, 30, 100. This is 40. This is 60. Okay. Rarely comes here. Dirty. Easy. Easy, you go there. Okay, and rarely is this. So easy, 60. Rarely, 30. Then you have to take away when these two happening at the same time, rarely and easy, which is 14. So just press your calculator. So I have to come down here a bit. You press your calculator, you get 30, 60, 90, take away 14 with 76. Okay, D. Take note of the keyword given that. What is given that? Given that is if. If what? If easy. And which one you going to look at for easy? Occasional. Okay, I just put this occasional. So we're going to look at occasional. You're going to write down. You need to have occasional. You don't need to write the whole thing. Just write something representative. If easy. Right, so easy, the whole thing easy is only 60, so it's over 60. And how many is under occasional? It's 20. So it's 0.33, 1/3. So we have 4 types of questions here already. So we have the last question asking you some concept. Okay, asking you some concept. Ask you, are the events often visit and not easy mutually exclusive? Often visit, not easy is here. Are these two mutually exclusive? That means if someone often visits the store, can the person finds it difficult to locate the store? Finds it not easy to locate a store? The answer is yes. That means these two can happen at the same time. But now we use statistics. Since we are learning statistics, this topic, probability, we're going to use a probability way to answer this question. Right. So the logic is here. This is a concept. I just write the concept so that you know what is it. If often and not easy are mutually exclusive, then probability that they happen at the same time, often and not easy, should be at 0. Okay, if often and not easy are mutually exclusive, then the probability of they happening at the same time is cannot. If they are mutually exclusive, that means they cannot happen at the same time. The chance of they happening at the same time with this word "and" it will be at 0. So let's find out what is this. Often and not easy. Often, not easy. So how much? 14 out of the total, which is 100. Now you just need to know that, okay, it's not a 0. It's a 0, then they are mutually exclusive. Now you find that it's not a 0. Since this is not a 0, so they are not mutually exclusive. Clear? You know, theoretically, common sense, you know that they are not mutually exclusive because they can happen at the same time. But now you just need to use statistics, the way you do probability to prove, to answer the question. So how do you do it is you just need to find out the probability of they happening at the same time. Can they happen? at the same time, the chance of it happening at the same time is 14 over 100. If this is not a zero, that means there is a possibility that they can happen at the same time. If they can happen at the same time, then they are not mutually exclusive. That is the answer. Okay, so the last 4 slides, starting from here, this question, A, B, C, D, and E. Okay, so this is the key questions in this topic. If you are comfortable with that, then you got the concept correct. If you are not too sure yet, you may want to just go through again and answer and understand the questions. Yeah. So at the same time, before I see you again for the next lecture, right? Next lesson is a tutorial, so I won't be touching anything off. Yeah, I let you do something first before we discuss. So we are not going to touch anything in our next lesson, which is a tutorial. You continue to do the balance. Okay, so just now we have this. This is also a homework, right? This is also a homework. Then this is also a homework here. Then the rest. Question 3. Question 4. Question 5. Yep. You should be able to answer all the questions because they are all the same. And the answers are all at the bottom here. Clear? Okay, so we will stop here now. Okay, you cannot see. So since when you cannot see? Because there is a disconnection. So it's 2:53. Okay. Don't worry. We will see each other again next lesson. I will just touch a bit on that. Okay. 2:53. So we should be discussing the last question. Can you still hear me? Okay. Right. So later you can take a break first because you've been sitting down here quite a while. So you take a break first. When we start off, before I start off the tutorial session, I will show you again the questions. Yeah, it probably is an exercise. Am I right? It's exercise that you didn't see. Am I correct? From where, from which slide that you can see? Exercise 2, yeah. So exercise 1, is it okay? Okay, good. So I will start with exercise 2 and I'll do it over again for exercise 2. Right. So at the moment, I'm going to show you where you find your this tutorial question. Can you go to additional resources where you find the tutorial question, you find the formula. I just uploaded a tutorial questions for this coming tutorial session. Okay, you just download it, have a look at that. If you have a printer at home, that will be good. You just print out and you can do the things on top of it. Otherwise, you can do those in your exercise book. Right, so I think this one is the one. We'll discuss this. Clear? Okay, I will go through starting from exercise 2 until the end that I have said just now, right before we start our next lesson at 3:30. Correct? Yeah. So you get your tutorial questions, right? The questions for the tutorial session. Okay, so take a break first. I'll see you later.